Okay, we're going to move ahead and go to something called assigning oxidation numbers. This is actually not awfully difficult. Now you're going to have to remember that group 1, or the alkali metals, has a positive 1 charge, because this is the reason why we go through this as far as doing things, because we always see it again. So I'm going to go ahead and write down the charges. Let's see, are there any others? Well, we know Al is a positive 3, zinc is a positive 2, and Ag is going to be a positive 1. So you're going to notice this is really nice because we do have these guys, red region, they only have 1 charge. Now, we also need to remember that in most cases, hydrogen is going to be equal to a positive 1. And then you have your ones that are kind of the same. Oxygen likes being a negative 2. So, it's nice that it's a negative 2 because it's a constant. I'm going to zoom in a little bit. And what we're going to do is we're going to assign oxidation numbers. I call this the go with what you know. Well, first of all, we have to remember that if I write something like this, you're going to have to remember that that is a 0 charge, because it doesn't have anything up there. So my oxidation number is going to be 0. We also have to remember if I have something that's like this, which is a metal, we also have to remember this is 0. Just remember the rule: if it's by itself, it is a 0. And then I can go ahead and add as far as going through another concept. Now that doesn't apply for ones that are compounds. So first of all, we're going to just do the compound part. Let's go with ones that, we're doing Roman numerals. Now if you remember, if we were trying to figure out the charge or the Roman numeral, we needed to go with the last one. Now this one's simple because you guys said, or we remember that, you go on the other side. So if I have this, I'm going to have a negative 2. And then we also have to make this all equal to 0, so we got to make that a positive 2. So we just assigned the oxidation number for copper. Usually they're just going to ask you what the oxidation is for copper. And when we have the chlorine at this spot here, it's usually a negative 1. Usually. Sometimes it isn't. It just depends on how more complicated it is. Let's go ahead and do the Mn2O7. Again, we need to know that this one is 0. And we're going to go with this. We know that oxygen is a negative 2. A negative 2 times 7 is a negative 14. And now we have to make this all equal to 0, so we're just going to have to make that equal to a positive 14 to make this correct. And I have 2 of those, so my charge is going to be a positive 7. Now we did know on this one is manganese, Roman numeral 7, oxide. Again, kind of simple. Now let's go ahead and do ones that are actual formulas. So let's go CaCO3. And the common thing is, as far as this, they're always going to ask what the oxidation number is for your middle one. Or sometimes it's going to be the first one. Because we already know that when we have this, we have a positive 2 here, and this is a negative 2. They're going to say, well, what is the oxidation number of carbon? Well, we just have to know that this is going to be kind of like a simple addition-subtraction problem. When we started out, this one was a zero charge. Might be a common routine that you do for that. We know that this one's going to be a positive 2 because it's a positive 2 times 1. We don't know this one yet because they're asking for it. And then we have a negative 2 times 3, which is a negative 6. Well, what's going to make this correct? Well, if we do our higher level math, we know that this one's a negative 4. What's going to cancel out your negative 4? A positive 4. So what is the oxidation number of carbon? A positive 4. And again, they kind of change out. When you have ones like this without the parentheses, it is actually kind of simple. Let's go ahead and do NaClO3. Well, again, this is going to be what is the oxidation number of your middle one, which is chlorine. We're going to go with what we know. That's a negative 2. This is a positive 1. We have a negative 2 times 3, which is a negative 6. We know this one is going to be a positive 1 times 1, which is a positive 1. We have to figure out what's going to make this one correct. That's going to be equal to a negative 5. When I put these two together, have to make that equal to 0. I'm going to have to add 5. So my chlorine oxidation number is going to be a positive 5. Let's go with one that's going to be a little bit more complicated, but not awfully difficult. Let's go with BaClO2, that's chlorite, with a 2 outside of this. Now remember, you have your little tools that you can use kind of like in mathematics. We can look at this. First of all, it has to equal 0. We can put our Ba here, and then we can also distribute this 2 to the whole thing. So we're going to have Cl times 2, then 2 times 2 is 4. And so instead of just trying to figure it out by popping the charges here, we can actually distribute, and it'll make life a lot simpler. So we got a positive 2 here, a negative 2, because they're going to ask you what this one is as far as my oxidation number. Still going to be equal to 0. A negative 2 times 4 is a negative 8. We don't know this one. And then we know this one's going to be a positive 2. Just be a little careful with this because we know we have 2 of these. So we know in order to make this all correct, that's going to be equal to a negative 6. I got to make it equal to 0, so that's going to make it a positive 6. You just have to remember that I have 2 of those. So each one of those chlorines actually have a positive 3 charge. So that's how you figure out how to use an oxidation number for this. And again, it's not really that difficult. We just start adding a little bit more and more at a time. Let's go ahead and go with one that's a little bit different. So we're going to go MnNO3, and we're going to go with a, what kind of number are we going to put here? Because we can always do whatever. So we're going to do this. We're going to make the whole thing equal to 0. Again, we're just going to have to go ahead and do our distributing. So we got Mn. We got 5 nitrogens, and we got 15 oxygens. Again, we do process. Now, we do know that our oxygen's already negative 2. That's fine. We also can figure out that my Mn is a positive 5. Because that's my Roman numeral. And Roman numerals are my positives. Now on this one here, That's going to be the one you have to figure out because it's usually the one in the middle. So we're going to leave this as a blank spot. Positive 5 times 1, positive 5, negative 2 times this, negative 30. That's all going to equal a negative 25. So we're going to know that in order to make this correct, it's a positive 25. Now we can't have a positive 25 as a charge. The highest one's going to be 7. So we have our little indicator here, but that now I have to figure out what the charge is of each nitrogen. Well, if we divide 25 by 5, we know that if we put a positive 5 here, those are going to be equal. So my oxidation number for nitrogen is a positive 5. Let's go ahead and just do an ion. Well, let's do one that is a little bit abnormal. Those are the ones I said are not going to actually go according to plan. And let's say I wanted to try to figure out what the Roman numeral is for this one, because it doesn't follow standard things. We know this is going to be equal to 0. We know that the charge of each oxygen is a negative 2. Negative 2 times 3 is a negative 6. What's going to make this all correct? A positive 6. And I only have one of these, so that's going to be my charge. So if I was going to name it, it is actually manganese, Roman numeral 6, oxide, even though it looks like this at the bottom. So again, you got to be careful. Make sure you look at the last one. Okay, so we got a couple more we're going to do. Let's go ahead and try one of the ions. So let's go the chromate ion with a negative 2 charge. It doesn't really tell you or make any difference because we know that now we have to make this equal to a negative 2. And we already know, or should know, that we're going to figure out what the oxidation number is for chromium. And again, it will always tell you that. Just be a little careful with this because that's the charge for the whole thing. We know that oxygen is going to be a negative 2, so that is equal to a negative 8. We have to look at the difference between these two numbers to figure out my positive. So if I'm going to make this correct as far as my situation, I have to put in a positive 6. So that is my charge of the chromium in a polyatomic ion. Let's do another one, and then this will be my final one. Let's do the dichromate ion. And they don't really get more complicated than this. It is nice you don't have to deal with parentheses or anything. We know that the overall charge of this has to be a negative 2. We know that the charge of that's going to be a negative 2. So it's a negative 2 times 7, which is equal to a negative 14. We just have to look at the difference between these two numbers, which is going to be a 12. It has to be positive. Most cases, if you're finding these, they're going to be positive numbers. I have 2 of those with a positive 12 charge total. So the charge of each of these are going to be a positive 6 again. Again, it's kind of like simple adding, subtracting. It just puts things in a little bit different perspective. Now we're going to see how it kind of works with something called redox.